Hey everybody, Lisa over at I Repair On Devices, and today on my workbench I have this Bose CD3000 unit here. It's a radio CD combination. This is a Series 3. Up at the top here, we have the radio side controls, the preset stations, the on and off button. The center here is where you put your CDs, and then on this side over here is where you the controls for the CD. And then down here is the subwoofer speakers. So this guy came in all the way from Virginia. So a guy found my YouTube channel, saw all the repairs I've been doing, and contacted me saying, "Hey, I have a Bose CD. Do you mind taking a look at it? Take a look at it." Well, y'all know me, absolutely. When you sending it? So it arrived, and it came in. All he says was it's not turning on. So the first thing I look at is let's check the power cord. You want to start simple. So I checked the power cord. The power cord was not plugged into anything, and I did a continuity test. And if you've seen any of my other videos, continuity test is just testing each end of the wire. If you get a beep, it means it's working. So I tested both legs of the power cord. That worked fine. Set that aside. So the next thing is like, so it's not turning on. Now let's turn to the power supply. And this is the power supply board. This guy sits in the bottom, sits on the bottom there, and he's also connected to a transformer. So the next thing I did was let's look at the power supply board. Remove that, and I started doing some probing around. So the first thing, if you notice the board here, there's two ways you can feed your input. This guy over here, which is like an oval shape, this is your AC. This is your AC current. It would be, for us, 120. Abroad would be 240. And then this little circle here would be 12 volts, between 12 volts and 15 DC. This is a power brick that you would plug into there, like your laptops and everything. And you would plug that over here. Well, he was using the AC side of this. So if I turn the board over or turn it around here, one of the legs, when it comes in, it's being protected by a fuse. The fuse is saying, "Hey, I need to do my job here. If anything comes over my whatever it's set at, I need to open up. I need to protect whatever I have down the line there." And in this case, this one is rated at 250 volts at a half a amp. So it's 0.5 amps or 500 milliamps, depending on how it's labeled. All mean the same thing. And so I tested the fuse. It was bad. So I knew right there, stop, can't go any further. We need to replace the fuse, and that's where I'm at this point. But I want to go over how the power supply works. So let's say it's working. What it's going to do is now, after the fuse, it's going to go into this transformer here. Now, this transformer is a 10-to-1 ratio step down. So this is your input side. So it's going to take 120 volts, your 120 volts alternating current, and it's going to step it down to approximately 12 volts. It's a 10-to-1 ratio. So it's going to step it down. And it's going to step it down to 10 volt, approximately 12 volts AC. It's still alternating current. So we've got the input here, which is these two legs here, the red wires. And then the output is going to come here, which is the blue wires. All right. So the blue wire here is going to connect to this guy. After that, it's going to be fed into what's called a bridge rectifier. Now, this is where we are converting the AC current to DC current, because a lot of times the boards only run off a direct current, which is your DC. So we need to convert it. And the conversion is done with the full bridge rectifier, which is basically 4 diodes soldered together. Once the conversion is done, now it is DC. It's going to be approximately 12 volts DC, but it's not a smooth, clean DC reading. So we need this filter capacitor, and it's going to smooth out that line. It's going to smooth out, take out as much ripples as it can before it needs to go further down the road. And this is where this guy comes into play. This is a capacitor, an electrolytic capacitor. And this is going to smooth out the DC line before travels onward. Now, you have to be careful with these type of capacitors, the electrolytic capacitors, because they do store their energy. So when you're working on these guys, you will get zapped if you don't discharge them. So before I did any work on this board, before I did anything, I discharged this by shorting out the two terminals together, and it brings it down to close to almost 0 volts. And same with these little electrolytic capacitors. Now, they wouldn't harm you as much, but you want to take your precautions and short them out, because again, these can hold their storage for years to come. And again, that's why they're used in a lot of circuits. So instead of the circuit having to always turn on and off, this guy will store enough energy to keep it running consistently and then hold its charge. So when it needs to be brought back on, it's consuming less power and energy to run efficiently. So a lot of times this is what these are used for, the capacitors, and also to smooth out the ripples in the DC line before it travels down further into the circuitry. So at this point, this is where I need to stop and replace the the fuse, and see if this solved the problem. Now, there could be secondary issues, but I won't know that until I fix this guy first. So I figured I'd bring you along and show you how I'm going to do that. So the first thing I did was I did already remove the capacitor. You're going to, the fuse. So you're going to desolder it from the board itself. And here's my replacement one. Now, when you're working with fuses, you have to replace them with the, according to the specs that are listed on the board or in the schematics. Like I said, this one is rated, this is a 250 volt rated fuse, and it's for a 1/2 amp. Now, let's say, well, somebody asked me, well, Lisa, I have a 250 volt fuse, but it's 1 amp, 2 amps. You don't want to do that. The reason why is you're now allowing approximately 1 to 2 amps of current to flow down that line before it says, hey, I can't handle you. I need to open up. Well, in the meantime, anything along that line that's feeding this, it's going to damage the components. So in this case, Bose says, you know what, we're only going to allow a 1/2 amp to come through this line here because it's going to damage the transformer, the capacitor, the full, the bridge rectifier. We can't have that. So we need to have a small window of current to come through here before it does any damage. So it's only a 1/2 amp. Now, if I look at the fuse that's feeding the DC line, that fuse is fine. Why? Because it wasn't plugged in. It wasn't active. When the AC line is plugged in, it actually disables the DC line. So the fuse on this line works just fine. And it does not need to go through the bridge rectifier and the capacitor, because the DC voltage that's already coming in is already been stepped down due to the power brick itself. The power brick contains its own transformer and capacitors and bridge rectifiers to do the smoothing and the step down. So here, all that's done ahead of time, 12 volts coming in here, and then now it's going to already come over to these MOSFETs over here, which are these chips, which then are sent out to the secondary board up here, which is just basically telling it what inputs are there and what's enabled and disabled. So the AC line is where they're saying, you know what, we can't allow, so we can't, the input of the amount of amperage only can be this much before it needs to, do its job and open up. And that's what I did. That's what it did. So here is my replacement fuse. I have to solder it on. This is a glass type fuse, and it is a fast blowing fuse. It is 250 volts, and it's 1/2 amp, 0.5 amps, 500 milliamps. All the same thing. They will be listed differently, but it all means the same. Now, there is no polarity on these guys, so it doesn't matter which way I solder it on the board. It's not, polarity sensitive like the capacitor is. These capacitors are polarity sensitive. So this guy here that has a stripe, this is the negative side. The other side would be the positive side. So when you're working with components, some of them are polarity sensitive, others are not, and fuse is not one of them. So all I need to do is just add this guy on, and then I'm just going to plug him in and see if I am getting the required input voltage, and then I'll go ahead and connect it to the board. So we're going to get started here. So I'm going to go ahead and turn down or angle my camera down here so you can watch what I'm doing. All right, I have my gloves on here. I like these gloves. These are the textured gloves. And the reason why I like that is because I'm able to hold my tools. Nothing slips out of there. Like the other gloves you have are smooth. I've had a tendency of dropping my tweezers and everything, so I like the texture on these guys here. So here is my fume extractor, because I am going to be soldering with leaded solder, and you don't want to inhale that stuff. So this guy is going to suck all the nastiness away from me into the carbon filter. And then this is my soldering iron here, and we're going to go ahead and turn this guy on and get started. So first thing you do is just bend these legs in a downward position. All right, so this is how it's going to be. And I already cleaned off the part of the board where the old fuse sat. All right, you see this symbol here? That is a fuse. And I already desoldered it and cleaned the holes out, so we are good to go. I wrote bad in there because I know I always label the part of the board that I'm working on. So as you can see, this guy is good to go. He's already been cleaned out. So all I need to do now is just slide him into place. All right, so he's in place. And then now the back here is where I need to tack down these two sides to make connections to the board. All right, so here is my leaded solder. The reason why we use leaded solder because it has a quicker melting point. So, and it is, you gotta pay, you don't want to inhale this stuff, so that's why the fume extractor is on to, like I said, to take the nastiness away from me, so I'm not inhaling it. Okay. Doesn't take much to tack down these little guys here. And after a solder, I know it's hard to bring it up, you want to have it look like an anthill. Kind of have like that little slope, and you know that's making a good connection. So these guys here, these long legs, we don't want them anymore, so we're just going to go ahead and cut them off. And I should have showed you beforehand, before I did this, but I did test it off on camera. Before you replace any component, you do want to make sure that component is working. And how to test a fuse is the same way checking a wire is put your probe on each side, and if it beeps, it means the fuse is good. I did it off camera, but you should do it before you put it into the circuit, because there are times you will get a bad component sent to you. So I'm just going to show you that it is working. You hear that beep? The fuse is good. All right. So, but do that out of the circuit before you put it in and tack it in place. Because if it's bad, you're gonna have to desolder it, and you're gonna have to do more work than if you tested it ahead of time. But I did it prior to turning on the camera. And now I'm just cleaning up the area with some alcohol. Clean away any of the residue from the solder flux and everything. Right, so we got two good connected legs here. All right, bring that up a little bit closer. Like it says, you want them to look like little ant hills. You want to have that nice, like a volcano, have that nice slope looking to it. And I know it's connected to the traces on the board itself. There's no little holes. It's making a good connection to the actual legs themselves. And then here is the fuse on the board that I just replaced. All right, so now here comes the scary part. You don't want to do this when you're doing this. You gotta, you know, be careful, because I'm going to plug this in, and this is live voltage that you're working with. So you want to make sure you're taking all the precautions necessary. I still get nervous when I do this. I've been working on, you know, power supply boards for many years, but you want that nervousness because it keeps you more alert. You don't want to lax when you're doing this, because that's when you start making mental mistakes and everything. So it's good to have that little adrenaline rush, because it keeps you more on your toes and everything. So I have to go get the power cord. I set it off to the side. So hold on one second. Okay, now I'm going to plug in the transformer, because we need the transformer plugged in, because that's going to step down the AC voltage from 120 to approximately 12 volts. Okay, so we got everything plugged in. I don't need... unplug that, plug that. So, right, gonna turn off my power strip before I plug anything in, so I can plug the power in here. So, and I'm going to show you one thing real quick here before I plug anything in. So, like I said, when you look at the capacitor here, we'll see that. Give you a demonstration that I had already discharged it. I'm going to set it to DC, because mind you that it had already been turned over. It's already been converted from AC to DC. Out of the way here. So my negative probe is going to go on the negative side. Where is it? Right there. And then the positive. So as you could see, now you're going to have some variance here. It's just the air that's causing like these little millivoltage. But so as you see, I have nothing on this line here. Okay. Now watch what happens when I plug it in. Let's just make sure we're getting everything first before I start messing with anything. So we're going to go ahead and plug our AC line in. Right now, my main power supply, my power brick is off still. All right, so I'm safe to touch this, because the main power, the main 120 is shut off at this point. Okay, so now I'm going to go ahead and turn on the power supply. I'm sorry, the power strip. All right, and okay, it's on. So now this is where it's dangerous. So you got to be careful with what we do here. So first thing I'm going to do is check the transformer here. Now the transformer is running on AC. So I should have approximately 12 volts coming out. All right, what we've got there, I'm trying to read it back. 12.23 volts. So this is DC, or I'm sorry, AC still. So we have the input coming in of 120. So the fuse did its job. It's working still, because if the fuse did fail, we would not gotten voltage to this point. So we got 120 coming in, which I will, on the red lines here. And then it stepped it down. It did the 10-to-1 ratio, and it stepped it down to approximately 12 volts, still AC. And so now I'm going to, So I know the power supply board is working. All right, so now I'm going to go to the next step and put it back into the unit here and actually turn on, because like I said, there could now be secondary issues with the main board or the secondary board that sits at the top here. But I want to show you the capacitor once I turn this off. So it's still, I turned off the power supply, the power strip. I keep saying power supply. So I'm going to go ahead and unplug this from the power strip. So my cord is unplugged. Now again, you don't want to touch you don't want to touch this main capacitor here. Again, he's live. So I'm going to carefully, I'm going to undo the cable here. All right, so I disconnected the cable. And I'm going to carefully, I'm not touching anything on the board here. And now I'm going to show you what the voltage reading is on this capacitor. Negative. All right, oh, I got to change it to DC now because it's at the DC part. $14 volts. All right, you see that? It's 14 volts. And it's off, unplugged. So it's storing 14 volts there's 14 volts sitting in here. And this is what you don't want to touch. You don't want to touch these together because you will get a good shock. Now, a lot of times it could hold more, depending on what the circuitry calls for. So this isn't a high powering circuit, but still 14 volts will give you a nice zap, and that's not what you want. So I'm going to set this guy here. So what you do to, again, you got to be careful with this. So don't work on any board if you're uncomfortable. Okay. So what you need to do is discharge it. So what I do is I take a resistor. I have resistors that range anywhere between 20 and 50 watts. This is a 8 ohm resistor. And these are usually found in the cars when you're hooking up your stereos and stuff like that, the big woofer boxes and everything. So these are mostly found in automotive, but I use these in these circuits to discharge the voltage. So I'm going to show you what happens. So before I touch it, I'm only touching one side here, which I'm still okay. Nothing, I'm not touching anything else where I'm making a complete path here. And then I'm going to get these guys to just be quick here. And then I'm just going to touch this side. Come on, work with me. All right, all right. Again, we're not touching both sides, so I'm safe. And now, just taking one hand, and I'm just going to hold this side here. Okay, and I'm touching the negative side, all right? And what it's doing, it's dissipating the stored voltage in there. You only just need to hold it there for a few seconds. It doesn't take long. All right, and I will take another reading. All right, so I'm going to go ahead. You don't want to touch it all, so just one hand. And now we're going to take another reading. And there you have it. 0.043 microvolts. So I dissipated the current or the voltage successfully, so I can go ahead and touch this. But you still want to be careful. It's not something that you want to just sit there and you know, I'm safe. You always want to treat it as if it's still what I say loaded. But as you can see, that's how I dissipate the voltage. It's very simple to do, but it is nerve-wracking. But I know when I am nervous, it keeps me on more high alert, which you want, because there's times you do find yourself getting lax and you're like, oh, you know, ooh. So now we're going to go to the part of me now putting this back into the unit here. So let me get some things out of the way. Turn off my meter, set that to the side. I'm going to disconnect the transformer here because I need to put the big heat sink back on here, or the metal. We got this metal frame that needs to go back on here. So let's see here. I'm going to do this the right way. I want this all installed before I go ahead and test this. All right, so we're going to go ahead and put these 2 screws in first. I like to keep things sorted because sometimes these screws come in different sizes, and if you put the wrong screw in the hole, it's not going to end well. You know, you could strip out that hole. So you just put these, tap these guys back into place first. When I work with screws, I like to back turn it first, and then, you know, turn it the opposite way first and then go forward, because it realigns what do I want to say? You don't want to strip out these screws. So when I back turn it, it's lining up the, what do you call those little swirls there? I don't know, but all right, so let's get this guy in. I don't like to use drills in this case, because you can actually torque it and cause damage. So and I don't have my other screwdriver here, which I like to use, which is that ratchet type, but this is fine. All right, so we got this block on, so now we have to add in the transformer. Get this guy lined up here. Where are you at? Let's see. Where's it away? There we go. Let's flip it over. Okay. I have another one of these coming in. Now this guy is semi-local. He's up in Yorkville, so he's either going to drive it down or ship it down to me, but I don't mind. These repairs. Now his it's going to be totally different. So, which I like. I like these. I like repairs that come in that are different. But I like all repairs in general. Okay, so we got one more screw here. Let's get my other screwdriver here. Now, normally a repair like this would, say it's only the fuse, only takes me about 20 minutes, but because I'm recording this, I'm trying to explain my troubleshooting process, try to explain a little bit more how these components work. So it is taking me longer for that reason, but normally I can knock these guys out pretty quickly. All right, so everything's there. So now we have to connect the board. And the blue wire goes in one way, and so does this guy as well. All right, so we got that. All right, so we got everybody reconnected here. So now I'm going to lay this guy down because he goes on the bottom here. So I'm just going to prop this guy up on my leg. And he just gets reset it back in place here. So we have a connector here. Now this red and black connector is for the subwoofer. So that has its own power. The power supply is feeding its own power to the subwoofer. And then we have a ribbon cable here, which is a 13-pin, not a ribbon cable, we have a 13-pin connector here. And this guy is connected to the top board, which is controlling the, that controls the on-off button from the remote and the, you know, turning on and off the inputs and everything. So, all right, so this guy just gets slid down into place. And I'm just gonna tack the back on with just a couple of screws. I'm not gonna put them all on, just enough just to hold it in place. Because I don't like to have the stuff laying loosely when I'm flipping it over and everything. So I'm just gonna, like I said, tap it down with a couple of screws here. Like I said earlier, there could be secondary issues, but in order for me to move forward, I had to solve the first one, which was preventing any input getting to the power supply board. So I had to solve that one first before moving forward. So let me just get one more here. All right, let's turn this guy around. And let's bring the camera up here. So now we're going to go ahead and plug this guy in to the back here. So right. All right, so now we're going to go ahead and turn the switch on to the power strip. And now it's being fed power, so let's go ahead and turn it on and see if this solved it. Well, look at that. Oh my God, I don't know what station it is. Let's go down to one of my favorite stations, country. Look at that. So that solved the problem. So we had a bad fuse. That was a nice, easy repair. I'm going to go ahead and, of course, clean the boards, and I'm going to clean the CD and everything. But let's go ahead and test the CD. So let me turn this guy off. And let's see if there's any issues with the CD. I will definitely clean the optical lens and everything, but let's just start. Like one of my favorite, not favorites, but somebody left this CD behind. It's monks, and a bunch of monks chanting. Interesting. So I use this as one of my tests. So let's pop this guy in here and see what we've got. All right, so radio's back on. And volume works fine. High, low. Numbers are moving fine. So let's hit CD play. Okay. All right, that sounds a little... The wheel needs to be clean, but it is starting up. Okay. Let's scan forward. All right. Some more. And let's scan back. Let's stop it. And go back to the radio. All right, so there you have it. This was a successful repair. The only issue, luckily enough, was just the fuse. Why did the fuse blow? Most likely it was a power surge, because he did say that they did have a storm come through, and once the storm hit, that's when it failed, and most likely they had a power surge on that line that was feeding to this, that the Bose was fed into. So this was a simple repair. You have, like I said, you have to be careful when you're working with these, when working with components that store its energy and stuff like that, because you can, get a good zap. Um, and let's say you put the fuse in and it popped again. Well, if you keep replacing the fuse, there's something else down the line causing that. So say if I replaced the fuse and it popped again, well, next I'm going to look at, okay, let's look at the transformer. Can the transformer be causing an issue? If the transformer passes its test, let's look at the bridge rectifier. Let's look at the capacitor. Let's look at whatever's on that line, because that could be also causing the fuse to fail. But because I turned it on and it's working fine, and listening to the customer, because you want to listen to what they're saying, or what happened at the time, because that's going to give you an idea of the problem. And when he says, a storm came through right away, that's what happened, is a power surge came along that line. And like I said, that fuse is rated at a 0.5 amp. So when that line, had a power surge come through it, it said, oh, Jesus, you're just too much. I can't handle you. And it did its job. It opened up. It failed to save the rest of the components down the line. So this was a, successful repair. The only thing I need to go back is just clean off that board, because it is dusty. I got to clean the optical lens. I'm not going to do that on camera here, because I usually take it off, go underneath my microscope, because I like to see the glass that I'm cleaning, because you can easily scratch them, and then also clean the rails and everything that the mechanism drives along and everything. So yeah, so this was a good, successful repair. I hope you enjoyed the video. I hope you learned something. And well, y'all enjoy the rest of your weekend, and I will talk to you soon. Bye.